Here is grade 7, module 8, lesson 1. Our I can statement for today is I can solve one-step inequalities by applying properties and graph the solution on a number line. So at the top here we have a couple important notes to remember. So we're going to go through and highlight what we need. This says the properties of equality you used when solving equations hold true for inequalities. For inequalities, unless you multiply or divide by a negative number. When you multiply or divide both sides of an inequality, by a negative number, you must also reverse the inequality symbol. So everything will be the same as with solving equations, okay? Except when we're talking about multiplying or dividing both sides of an inequality by a negative number. And when you do that, you need to reverse the inequality symbol. Okay, so if it was greater than, then you would change it to less than. If it was greater than or equal to, it would be less than or equal to, or vice versa. So here's some examples for you. When graphing the solution to an inequality on a number line, an open circle represents less than or greater than. So an open circle is less than or greater than, and a closed circle is used to represent less than or equal to, or greater than or equal to. I always think of that like or equal to. This little line here fills in the circle. While over here there is no little line, so it's an open circle. Just little things to help you remember. Okay, so here's some examples. We have x is greater than -1. So there isn't any or equal to sign, so we have an open circle. And then we're talking about values that are greater than -1. So, for example, 3 is greater than -1. 5. 0 is even greater than -1. All of these numbers, 1.2. All of these numbers are greater than -1, so our line is going to go this way. And that's your answer. If we were to flip it, x is less than 1. So that's saying what values of x will make this true. So like, for example, -10 is less than 1. So -10 way over here. 0 is less than 1. -5.43. -5.43, somewhere around here. Those are all values of x that are true. All of these values of x are less than less than 1. And we have that open circle because it is not an or equal to. 1, because if we plug in 1, is 1 less than 1? No. It could be or equal to, but then we need to fill in our circle. But for this example, it isn't. So 1 is not less than 1, so 1 can't be a solution. Let's look at some values of x that would have a closed circle that could be the same number. So like -1, if I substitute -1 in for my x, -1 is greater than or equal to -1. That's true. It's or equal to. So I'm going to fill in my circle because 1 is a value of x that makes this inequality true. So let me say that one more time. -1 is a value of x here that makes this inequality true. There are other numbers, though, that also make it true. like, let's see, numbers that are greater than or equal to -1, 3, 33. Ooh, 33 is greater than -1. It's like somewhere way down here. 0. 0 is bigger than -1. These are all values of x that are greater than or equal to -1. So our line is going to go this way. If we were to plug in a number on the other side, let's say -10. Is -10 greater than or equal to -1? Remembering our negative side of our number line is kind of backwards. Okay, -10 is actually way down here. So it's less than. Okay, I would rather have -$1 in my bank account than -$10. -10 is, you have a lot more debt than just -$1. Okay, on our last one here, we have x is less than or equal to -1. Or I'm sorry, x is less than or equal to 1. It's or equal to, so we're going to fill in our circle. Less than or equal to 1. So what values for x could we plug in here that will make this true? We could do 0. We could do -3. -3 is less than 1. You could even do 1/2 right here, or -1/2 right here. And those will all be values of x that make this true. So with your inequalities, there are multiple solutions. Okay, this is a solution, this is a solution, this is a solution. Right next to that, right there, is a solution. With equalities or equations, you have something like x equals 3, where this answer is your only answer. With inequalities, you are going to have multiple answers, okay? Multiple solutions to your inequalities. So down here, we have a water tower that holds 1 million gallons of water. There are 650,000 gallons in the tank. Write and solve an inequality. Write, solve, and graph an inequality that represents the gallons of water that can be added to the tower before it's full. So we need to first identify the unknown value and assign it a variable. So we have an unknown value of the number of gallons of water that can be added. So this is actually what we're solving. How many gallons can be added to reach, I'm going to draw a little pretend tank here. So max, we would have 1 million. And there's already, it's water, 650,000 gallons in there already. We need to figure out how much more we can put in there. So that's going to be our W. We need to write an inequality to represent this situation. So we're going to have our 650 plus our W. So our 650 plus our W is less than or equal to, because it can be 1 million, it can go right up to the top of that tower, but it can't go over. So that's our inequality. We need to solve it. To do that, we're going to do those same steps that we did for equations. We have 650 on one side. We're going to subtract that from both sides of our inequality. And just a reminder, the only time we switch our signs is with multiplying or dividing negative numbers, not adding and subtracting, just multiplying and dividing. So we subtracted 650,000 from both sides, which leaves just W on this side. And we're going to have 350,000 on the other side. So what this means is that you can add 350,000 and you could add 340 or 330 all the way down to 0. Okay, you could add nothing, and that's a possible solution, or 100,000. Anything between 0 and $350,000 or gallons is your solution to this inequality. And we're going to have a closed dot because it could go all the way up to the top of the tower and equal that height, but it just can't go over.